Question number 12. A student states that if an object is in equilibrium, sum of the clockwise moments about a point x is equal to sum of the anti-clockwise moments about a point y. Let us say I take something like this over here. It's in equilibrium. Okay, now sum of the clockwise moment. Let us say there is one moment here, there is another moment here, another moment here, another moment over here. Forces are acting like this. It's pivoted about the center. Okay, now sum of the clockwise moment is equal to sum of the anti-clockwise moment. Okay, let me say one more also here. Okay, that's what it says. That's the right one. So which condition would make the student's statement correct? Now either x or y is the center of gravity of the object. What is it? If the equilibrium sum of the clockwise moment about a point x is equal to sum of the anti-clockwise moment at a point y. See, actually this statement is true. Okay, if only when x is equal to y. X is equal to y. What do you mean by that? That means if I consider x as one point here, another point y here, and I take the moments about these points x and y separately, this will not be correct. Okay, you should choose one point, and with respect to that point you should choose whether the clockwise moment, sum of the clockwise moment is equal to sum of the anti-clockwise moment. I can write like this: sum of this clockwise moment is equal to sum of the anti-clockwise moment about one point. Remember this. So therefore either x or y is center of gravity, not required. This is not the right answer. X or y is a pivot of the object, not x or y. There should be only one point. X and y should both. There should be an and over there. This is all the other one. X and y are the opposite ends of the object. No, x and y are the same point on the object. D is the right answer. It should be lying on the same point. It could be middle over here, or it could be anywhere, but it should be the same point.